A very good morning, one and all. Myself, Dr. K. Kavitha from ECE Department, Marri Laxman Reddy Institute of Technology and Management. And my subject is electronic measurements and instrumentation. And already we discussed in the previous classes that what is the basic performance characteristics, that static and dynamic characteristic, what are the parameters are there in static and dynamic characteristics, and how we are going to calculate and each and every parameter with the help of that static and dynamic characteristics. And this we learned in the previous unit, that is the unit 1. Then next we discuss the unit 2, that is the signal generators and signal analyzers. And now we'll discuss the what are the types of the signal generators and introduction to signal generator, and what is signal generator and what is oscillators we'll learn in this class. Okay, next, introduction to signal generator. This is what is the signal generator? Signal generator, the name itself, it generates some signal. It generates the signal with amplitude and the frequency and time. And what are the types of the signal generators? And there are the two types of the signal generators. And first is the standard AF sine wave and square wave generator, and pulse and square wave generator, and function generator, and video signal generator. Before going to the signal generator, we should learn what is oscillator. Oscillator is nothing but without giving input, we'll get the output. And what are the types of the oscillators? We know what is the oscillator. Oscillator is without giving input, we'll get the output. There are the two types of the oscillators. Those are AF oscillator and RF oscillator. What is AF oscillator and what is RF oscillator? We'll learn what audio frequency oscillator and radio frequency oscillator. What is the audio frequency? What is the range of audio frequency? Is the 20 hertz to 20 kilohertz, and the range is 20 hertz to 20 kilohertz. That is the AF frequency range. The above the AF frequency is the radio frequency. Above this is the RF frequency, radio frequency. Then these are the types of the signal generators, that is the standard AF sine and square wave generator, and function generator, and video signal generator, and pulse and square wave generator. This signal generator, we are going to generate the different types of the signals, that is the sine signal, square signal, and triangular signal, and pulse signal. For example, we'll take the function generator. In laboratory, we'll use the function generator. Function generator will generate the three types of the signal, that is the sine and square and triangular and pulse signals. We are going to generate with the help of this function generator. That is not only all the function generator generate these all three we have many signal generators. Those are the pulse and square wave generator, and function generator, and video signal generator also. Okay, well, now we will discuss the what are the types of the signal generators. In that, sine and square wave generator, pulse and square wave generator, function generator, and video signal generator we learn in this video. Okay, then next, before already we discussed the what is the oscillator. Is a circuit which produces to continuous repetitive alternative waveform without giving any input. Without any input will generate the output, that is the oscillator. Already we discussed the oscillator is basically it converts the unidirectional current flow from a DC source into the alternative waveform, which is the desired frequency as desired. It's the circuit components. Then the basic principle behind this working of oscillator, it can understood by analyzing the behavior of the LC tank circuit. This is the principle of this oscillator. Already we discussed there are the two types of the oscillators, right? That is, one is the AF oscillator and RF oscillator. And again, we have to discuss what is the mm, here we'll discuss the two types of the oscillators, right? Audio frequency range is already we discussed 20 hertz to 20 kilohertz. Above this audio frequency is radio frequency. Again, a audio frequency is divided into two types, that is the fixed frequency fixed oscillator and variable oscillator. What is fixed oscillator and variable oscillator? Is fixed oscillator is nothing but it generates the fixed frequency or fixed amplitude signal. We don't want to change anything, that directly the output will be get whatever we are giving the input, that is directly without changing the output, that is generate the pure signal in this fixed AF oscillator. In this variable AF oscillator is nothing but we are going to generate the signal, and with the help of we have some knobs to change the frequency or voltage. With the help of that, whatever the frequency with the signal, with the amplitude, we are going to monitor, we are going to vary that frequency or voltage. We are going to get the desired frequency with the help of this variable frequency oscillator. These are the two types of the oscillators in the AF. Okay, the next, the what are the applications of the oscillator? It is the we are going to use the quarter watches, and we are going to use in various audio systems and video systems. We are going to use these oscillators, and it is used in radio or TV and other communication devices. We are going to use this oscillator, and also this will be used in computers and metal detectors and stun guns, inverters, ultrasonic and radio frequency applications. Also we are going to use these oscillators, and it is used to generate the clock pulses for microprocessors and microcontrollers. Also we can use these oscillators, and it is also used in alarms and buzzes. It is used in the metal detectors and stun guns and inverters and ultrasonic. It is used to operate the decorative, that is the lights, that is the dancing lights. Where these are the applications of this oscillator. The next is the signal generator. What is signal generator? Nothing but the signal generator is an electronic circuit. It will generate the repeating or non-repeating waveforms. The waveforms with the different shapes and amplitudes. Signal generator, here we are, by using this signal generator we are going to generate the sine signal or square signal or triangular signal. We are going to generate with the repetitive or non-repetitive is nothing but if one cycle is completed, the same cycle with the same amplitude and same frequency, we are going to repeat the same frequency. We are going to generate continuously with the help of this signal generator and non-repeating waveforms. And these are, they are the different types of the shapes and different amplitude we are going to generate with the help of this signal generator. The signal generator is an electronic equipment that provides that standard sine waves like sine, square, triangular, already we discussed, etc. And it is also called an oscillator. It produces the periodic signals. And this signal generator, the name itself, it generates the signals with different amplitude and frequencies, and different signals, sine, square, triangular or sawtooth, we are going to generate the signals. And these signals are the, it will generate the pure sine wave and pure signals we are going to generate. There are the different types of the signal generators are there, and for every signal generator we have the block diagram, and we should I will explain that each and every block diagram and theory and also in these signal generators. in this signal generator we are going to use the basic signal generator. There are the two types of, that is the oscillator and attenuator. How we are going to generate a signal, we'll see in this signal generator. Okay, in this here, this is the frequency, set frequency. With now we are going to generate the frequency with a particular frequency. Whatever the frequency we want, we are going to select the particular frequency level. And attenuator, what is the function of this attenuator? It reduce the signal, and whatever our requirement, it reduce that particular signal, and it is give it to the RF output. And attenuator is electronic device. It reduces the power of the signal without distorting its waveform. Okay, these about the basic signal generator elements, oscillator and attenuator. Then next, what are the types of the signal generators? Already we saw in the first only, that is the standard signal generator. How we are going to generate the standard sine wave with the help of this signal generator. And what is the audio signal generator, and what is the radio frequency signal generator, and pulse and square wave generator, and function generator, and video signal generator. Okay, we'll discuss first the standard signal generator. In standard signal generator, what is the standard signal generator? The standard signal generator, it produces unknown controllable voltages with sine and square and triangular and pulses also. Okay, we are going to generate the standard sine, standard sine generator. We are generating the pure sine wave signal. It is used the power source for the measurement of gain and signal to noise ratio, bandwidth and standing wave ratio and other properties. It is extensively used in the testing of radio receivers and transmitters. We are going to use this signal, standard signal generator, to test the signal, and we are going to design that signal, and we are troubleshooting that signal in this with the help of this standard signal generator. Is used to designing and testing and troubleshooting and repairing the signal with the help of this standard signal generator. We are going to design that signal. For example, I designed the signal, this is the circuit. I have to design that signal. For example, I am giving the sine signal with the amplitude is the 5 volts. This is the amplifier. So here we have to get the output is the, if the output, we have to test that signal. After designing, we are going to test that design circuit. For example, I gave that input is a 5 volts. While testing that, we should get the output is, we have to get the above 5 volts. Above, greater than 5 volts we have to get in this. While checking that any circuit here, the whatever we are giving that signal, with amplify the circuit, which amplifies that signal with the help of, and amplify that signal with the help of this amplifier circuit, and we will get the output is the above 5 volts, 5, 6, 7, 8, or like that we are going to get the, if it will get the above 5 volts, then the circuit is working, and we are going to test that signal. If any, we have to do that the troubleshooting also. If is there any signals are getting the disturbance in the signal, where is there any problem in that signal, then we are going to troubleshoot that signal. Wherever we are getting that noise or disturbance or any problem we are getting, we are going to troubleshoot that signal, and we are going to repair that signal, and we are going to give it to that audio signal at the output. Okay, the standards, this is the block diagram for standard signal generator. Here we are going to give the RF oscillator. RF oscillator is the radio frequency oscillator. We are going to use the above 20 kilohertz frequency range. So whatever the frequency we want to use, that frequency we are going to select with the help of these knobs, and we are going to select the particular frequency also with the help of this RF oscillator. The RF oscillator output is given to that wideband amplifier. And before going to that, the one more input is coming from modulation oscillator. So this is that RF signal. This is like carrier signal. This input is giving to the, this is considered that is the message signal. We are going to give it the input to that wideband amplifier. The main function of this wideband amplifier, it will multiply both whatever the signals are coming from the inputs, that is the RF, that the carrier signal and message signal. We are going to multiply with those signals, and we are going to get the signal with the help of this wideband amplifier. The output here, before going to give it the input to that wideband amplifier, the modulation amplifier oscillator is there, where we are going to set that particular modulation frequency, and percentage of modulation is nothing but that is the mu. We are going to select that particular frequency, modulation frequency, and we are selecting, we are going to set that modulation index also. And here we have to give the external oscillator, if any the signal is having the less frequency or amplitude, we are going to give it with the help of the external oscillator, and we are going to set that particular modulation frequency with the help of these two knobs. And that signal is the message signal is give it to that wideband amplifier. After multiplying both these message signal and carrier signal in this my wideband amplifier, after getting that signal, it amplifies that signal with the help of this wideband amplifier. After amplifying that signal, we are going to give it to that output attenuator. The attenuator will attenuate the signal, whatever the signal is coming from the wideband amplifier. As a requirement, it will reduces the signal strength, or it will increase the signal strength with the help of whatever the signal we required. Like that, that is the, with the help of this attenuator, will reduce the signal or increase the strengthening of the signal with the help of this attenuator as our requirement. The whatever the signal is, that signal is coming from this output attenuator, are going to give it to that output level. So this is about the standard signal generator. Are going to generate the particular signal with the help of this RF oscillator and wideband amplifier, with giving the input modulation oscillator and external oscillator. Then we are going to give it to the attenuator. With attenuate, that's whatever the signal is coming from the wideband amplifier, it attenuate that signal and give it to the output. This is about the standard signal generator, and it is the instrument is provided with the means of modulating and the carrier frequency, which indicated by the dial setting of the front panel. The output of the signal amplitude modulator or frequency modulator, whatever the signal, it is that output of this signal is AM or FM, amplitude modulation or frequency modulation. Modulation may be done by sine wave or square wave or triangular wave or pulse wave. The next is the this is the signal generator which produce the periodic signal, is having the frequency or audio frequency range, is called as the AF signal generator. And this is the the standard signal generator, the AF signal generator. This is about the AF signal generator. The AF signal generator, we are going to generate the signal within the AF range only. Within the AF range is nothing but, what is the AF range? AF range is 20 Hz to 20 kilohertz. Within that only we are going to generate a signal with the help of this audio frequency signal generator. This is the range of 20 hertz to 20 kilohertz. Through that, few models produces the signals up to 100 kilohertz also. Then audio generator always produce the pure sine wave, and most also produce the square wave also. This audio frequency maybe look like this. We'll see here. This is the audio frequency signal generator. We have knobs. We are going to modify the any signals with the amplitude or frequency. With the help of this knob, we are going to adjust the particular frequency or amplitude levels. And we have knobs within the 10 kilohertz, 10 meters, like that. We have some ranges. These are the output. This is the sine wave. How we are going to attenuate the signal? With the help of this attenuator knob, we are going to attenuate the signal. Here we have the attenuator, right? With the help of this attenuator, we have knobs to adjust the particular frequency or voltage, whatever we want the signal. We are going to attenuate the signal with the help of these knobs. So this is about the standard signal generator. This is a signal generator, audio signal generator, audio frequency signal generator. And next is the AF sine and square wave generator. The AF sine and square wave generator, it will generate the sine wave or square wave, the radio range of the audio frequency based on our requirement is called as a AF sine and square wave generator. Here we have the Wien bridge oscillator. With the help of this Wien bridge oscillator, we are going to generate the sine wave and square wave generators. Whenever we switch on this, the wave, when our switch is connected to this sine wave amplifier, here we are going to use that amplitude level. Here we have to use the potentiometer to adjust the particular amplitude levels. With the help of that potentiometer, we are going to adjust the amplitude levels, and that is we are going to generate the sine wave or square wave. These are the sine wave block diagram, and this is the square wave block diagram. When we are going to connect the switch to that sine wave amplifier, then it is give it to that input is the sine wave is give it to here. The help of this potentiometer, after getting that output, we are going to give to the sine wave amplifier. Here the wave is amplifies with that whatever the signal is coming from the Wien bridge oscillator. We are amplify that sine signal and going to give it to that attenuator. It attenuate that signal as our requirement. The increasing or it will adjust the levels, reduce the voltages or frequencies with the help of this attenuator. With attenuate that signal, and it is give it to the sine wave output. Whenever we switch on this one, and it is the sine wave is give it to the square wave shaper. Here we are going to use that Smith trigger. We are going to use the Smith trigger. That is any type of the signal is converted into the square wave. That is the function of this Smith trigger. Any type of the signal is converted into square wave. That is a function of this Smith trigger. Here we are going to use the comparator or the Smith trigger. You are going to use to convert the whatever the sine wave signal is coming from here. We are going to convert that with the help of this Smith trigger. To convert the any type of the wave is it converted into the square wave shaper, and with the help of this square wave shaper, we are going to shaping that signal and give it to the square wave amplifier, which amplifies whatever the signal we are giving to that square wave, that amplifies that signal and give it to that attenuator, and it will attenuate the signal signal, whatever we are selecting here, the frequency signal, the same frequency is applied for that sine wave and square wave. We are getting that square wave signal here. Because this is about the AF sine and square wave generator. It consisting of the two path, that is the upper path is used to produce the AF sine wave, and the lower path is used to produce the AF square wave. Here we are, is the upper path is used to generate the sine wave, and the lower path is used to generate the square wave. We are going to use to generate the square wave. With the help of these two paths, we are going to generate with the help of the Wien bridge oscillator, produce the sine the range within the range of audio frequency only. Based on requirement, we can convert the output of the Wien bridge oscillator to either upper or a lower path by the switching of the switch. With the help of, we connect it to the switch to the sine wave, then we are going to generate the sine wave signal. When we switch on the square wave, then we are going to generate the square wave signal. And then the lower part is consisting of the square wave shaper and square wave amplifier and attenuator. With the help of the shaper, we are going to smoothing signal into square wave signal, and after that, where that square wave signal is amplifies that signal and give it to that attenuator, that attenuate whatever the signal is coming from the square wave amplifier. They will attenuate that whatever the signal is required, whatever requirement, and it is give it to that output. This is about the AF sine and square wave. Then next, RF signal generator. It produces the continuous wave, radio frequency signals, is defined as adjustable or amplitude and the frequency we are going to adjust. Already we discussed the oscillator and have a modulator. These are the RF generators consist of the three main sections, that is the oscillator circuit and modulator circuit and output control circuit. This is the RF signal generators is given below here. The external modulator, whenever the total modulator is controlled here, when we are switch on this here, internally we have the modulator, where we are going to give it to the oscillator which oscillate that signal. Without giving input, we are going to get the output, that is give it to the attenuator. Will attenuate the signal with the help of this meter. We are going to select the particular level as a requirement, and it is give it to that attenuator, and it attenuate that signal, and as our requirement, it is give it to that output. And this power supply, when we are switch on that power supply, the internally we have the modulator, and it is give it to that oscillator, and after getting that signal, we are going to adjust that signal and attenuate that signal and give it to that output. This is about the RF signal generator. RF signal generator is used for testing the system and audio and video broadcasting and satellite communication, radar and electronic warfare. The features of RF and microwave generators are almost same, except they have different frequency ranges. Microwave signal generators have much wide frequency ranges compared to the RF signal generators. Then next, coming to that, next generator is the function generator. The function generator, we are going to with the help of this function generator, we are going to generate the different types of the waveforms, that is the sine wave or square wave or triangular wave. We are going to generate, sorry, with the help of this function generator, we are going to generate the sine and square and triangular wave. With the help of this function generator, already we are using in this laboratory. The function generator will generate the different waveforms, sine, square, triangular, with the same frequency and amplitudes. And the function generator has the capability of producing of the wide variety of waveforms and frequencies. The most common output waveforms are sine wave, triangular waves, and square wave and sawtooth waves. The instrument, it is an instrument is used to provide the sine, square, triangular, and sawtooth waves. The frequency range is 0.01 Hz to 100 kilohertz. The function generators are also capable of generating two different waveforms simultaneously. Then what is block diagram of this function generator? How we are going to generate three different types of the signals with the same frequency and with different waveforms. How we are going to generate, we'll see in this with the help of this block diagram. This is the function generator. We have knobs, we have the channel 1 and channel 2, and we are going to select the particular channel, and we are going to select the particular frequency and amplitude with the help of these knobs. This is a block diagram, how we are going to generate at a time with the different types of the signals in one display. Okay, here this is the external frequency controller. Whenever we switch on, the total frequency is controlled here. Whenever we switch on that function generator, the external frequency controller is in on state, then that frequency is given to that frequency controller network. The frequency controller network, the function is the main function of this frequency controller network. It will select the particular frequency and it is given to the frequency controller. The whatever we are selecting here frequency, the same frequency is same for all the different three signals. After selecting the particular frequency with the help of this frequency controller network, it is given to the upper constant current source and lower constant current source. With the help of this upper constant current source and lower constant current source, whenever it is in on state, whenever the upper constant current source is on state, who will tell that switch on upper constant current source and switch off the lower constant current source? Who will give the input? The voltage comparator network will give the instructions to the upper constant current source and lower constant current source. Here the voltage comparator multivibrator. What is the comparator? The compare the two input signals and two incoming input signals. It will compare the two incoming input signals, and for example, this is the comparator. Here I am giving that this is the reference voltage, and this is the capacitor voltage. Whenever the capacitor voltage I am giving that 5 volts, I am giving the reference voltage is already inbuilt. We have this reference voltage. This is the 5 volts reference voltage. Sorry, this is the capacitor. Whenever it reaches the reference voltage, whenever it is reaches the capacitor is reaches the reference voltage is 5 volts, then output we will get the 0. And when we will get that 0, at that time we are going to give it that here start, here the upper constant current source in on state and lower constant current source in off state. Okay, whenever the input, the function here voltage comparator multivibrator is giving the instructions to the upper constant current source. Whenever it reaches that reference voltage to the capacitor voltage levels, then it is give the instructions to the upper constant current source is in on state and lower constant current source in off state. Okay, so here whenever it upper constant current source in on state, the current is flowing through this integrator. What is the function of this integrator? It will charges the capacitance, right? Whenever upper constant current source, the constant current is charging here the plus I. Whenever it is reaches to the reference voltage, for that time it is continuously charging. Whenever it is reaches to capacitor reference voltage to the capacitor voltage, then it will start to discharging. At that time, mm, the lower constant current source in off state. Here once again I'm repeating, whenever the upper constant current source is on state, the constant the current is flows through the integrator, and current is charges the current, and it is gives the current, and it is discharge the current. It charges the current, is discharges the current, or it is giving the current to the integrator, or it is taking the current from the integrator. It is giving the current and it is taking the current from the integrator. Here whenever the capacitor charges, then we get the some signal here. This a sine signal here, where squared signal we are going to give it that output directly. It is give it to that signal is the triangular signal. Here with the help of this comparator multivibrator, that is converted that is signal into the square signal. After getting the signal, we are going to amplify that signal, and whenever it is discharges is nothing but whenever it is reaches the reference voltage to the capacitor voltage, at that time it is in off state. Then whenever it is reaches the level, it is charges to 0 to 5 volts. Whenever it is reaches the reference voltage, it suddenly it will gets recharges. This is the plus I, charges the current is minus I, discharges the current to the particular level. Whenever it is reaches that level, and again it is starts to charging. Like that we are going to switch on or switch off this level whenever it is reaches that reference voltage to the capacitor levels. Here from 0 to here plus I, it is charges, and this is the plus I to minus I, it is discharges the current. That is taking the current, it is giving the current, it is taking the current. Whenever it is in on state, the upper constant current source is in off state. At that time, the current is discharges, the current is taking from the integrator, it is giving and it is taking from the integrator to the certain level, whenever it is reaches the capacitor level to the reference voltage. That directly the output is given to the triangular level. With the help of this resistor diode shaping circuit, the smoothing the sine wave signal is directly converted into the that square wave. Triangular wave is with the help of the resistance and diode shaping circuit, whatever we are getting that triangular signal, with the help of this resistant diode shaping circuit, it smoothly it is converted that triangular wave into the smoothing sine wave signal, and it is give it to the output amplifier to the second wave. Then we are going to generate that square and triangular and pulse signal. With the help of this frequency control network and upper constant current source and lower constant current source, we are going to generate the same frequency of the signal with the different types of the waves, sine, square and triangular. In this we are going to generate this like this we are going to generate the signals in the function generator. Then function generator is the piece of electronic test equipment or the software. It is used to generate simple waveforms. The major difference between function generator and audio generator is the number of output waveforms. The audio signal generator is produce only sine waves and square waves. While almost all function generator produce the basic waveforms, pulse triangular waves. The important feature of function generator is their capability of the phase locking to the external signal source. Usually the frequency is controlled by varying the capacitance in the LC and RC circuit. In this instrument, the frequency is controlled by the varying the magnitude of the current which drives the integrator. The frequency control voltage regulated to constant current source, that upper constant current source and lower constant current source. We are going to use with the help of the capacitor, and we are going to increase or decrease this with the help of whenever it is reaches that capacitance value to the reference value. The help of that we are going to generate that signal. So the A out and 1 by C 0 to T, with the help of this current is changes with the capacitance values. Okay, and increasing or decreasing the current slope of the output voltage and controlling of that frequency, the voltage comparator multivibrator, it will changes the state at the predefined maximum level of the integrator output voltage. This change cut off the upper constant supply, switch on the lower constant supply is on off. Whenever it is reaches the particular reference level to the capacitance level, then it will discharges the current. Whenever that time the lower constant current source is in on state and upper constant current source in off state, at that time is the current is discharges, and whenever the upper constant current source is on, the lower constant current source in off, at that time the current is charges to up to required level, and this is the current is giving to that integrator and discharges to that particular level. And what are the applications and specifications of this function generator? What are the applications? Are they are used for testing the amplifiers, filter and digital circuit. And the typical specifications of the function generator may be expressed as follows. The output waveforms is like sine wave, square wave, ramp, pulse, AM and FM modulated arbitrary, and frequency ranges from 0.001 Hz to 20 megahertz. The frequency stability is 0.05%. The distortion is minus 55 dB below 50 kilohertz and is minus 45 dB above 50 kilohertz. And the one more application is the output amplifier, that is open circuit, that 10 and the impedance is 50 ohms. And this is the difference between the signal generator and the function generator is very important. The signal generator, it generates the signal with sine wave only. The signal generator will generate the pure sine wave with the help of this signal generator. With the help of this function generator, we are going to generate the many waveforms like sine, square or triangular or sawtooth, etc. This frequency stability is limited in the signal generators, and this function generator, the frequency stability is very high, and the frequency is controlled by the frequency range controller, and frequency controller is controlled by varying the magnitude of the current which drives the integrator. This is about the signal generator and what are the types of the oscillators and what are the types of the signal generator. And we have one more signal generator, that's the pulse and square wave generator and video signal generator. We'll discuss in the next class. Thank you.